Now we've got a new function, g of x, 3 plus 2 ln x. We want g to the minus 1. So put y equal to 3 plus 2 ln x and make x the subject. So we'll take off 3, divide by 2, and do e to the power of both sides. And that tells me the inverse function is e to the x minus 3 over 2. We're going to want the domain of that function. We need the domain. So we're going to look for it. We need the range of the original function. So the ln x graph looks like this. It's the x-axis at 1. The domain of our function, though, is just greater than or equal to 1. So we're just looking at that part of the graph. We do 2 ln x, well, that will double the y values. And then when we add 3 to it, we'll move it up by 3. So the range of g is greater than or equal to 3. And that's the domain of the inverse function. So x is greater than or equal to 3. And the last part, find the exact value of a for which g f of a is equal to 5. I've just found g to the minus 1, so I'm going to use that. So if I do g to the minus 1 of both sides, I get g to the minus 1 g f of a. Those g's kind of cancel because one is the inverse of the other. So I'll get f of a is g to the minus 1 of 5. You could think about the two functions. If we start with f of a and we do g to it, we end up with 5 apparently. That's what the question told us. But we can look at the other way, going the other way. 5, if we do g to the minus 1 of 5, then we get f of a, which is what I've got there. F of a is g to the minus 1 of 5. G to the minus 1 of 5, well, I'll put 5 in the inverse function, e to the 5 minus 3 over 2, e to the power of 1, or just e. F of a is 2a over 3a minus 5. And then I just need to isolate the a's then. So I'll multiply by the denominator, expand the bracket out, get the a's on one side, and isolate the a, and divide. So it says a equals. Subscribe and request a solution.